So in tutorial 4, we stopped in this place exactly where we talked about Lagrange multipliers, which is alpha. What are Lagrange multipliers? Remember, in support vector machine, you need to calculate W, B, and also calculate the Lagrange multipliers. So that is what we are going to discuss in this tutorial. What are they and how do you find them? I would also like to remind you, as I used to say, subscribe to my channel so that you get notified when I make new lessons. Alright, so what are Lagrange multipliers? Lagrange multipliers are represented with the notation alpha. So they are, okay, let's display the example we are using. Lagrange multipliers are a measure of how much each vector or each support vector, or let's say each vector. Vector is simply all the data points, not just the support vector. Any of the data point is called a vector. So Lagrange multipliers are a measure of how much each of the vectors contributes to the boundary, and they are called supportive nice value. Well, you might be asking, what does this mean? How does it relate to support vector? First, supportive nice values simply tries to explain how each vector affects the decision boundary, right? So how does each of these data points or vectors affect the decision boundary? So how much weight does it add to the decision boundary? For instance, E, how much does it contribute or does it support the decision boundary? You see, E does not even support the decision boundary in the first place. So basically, points that are not in the gutter, I explained to you what gutter is, does not have any support for the decision boundary. Points that are not in the gutter. And remember, in support vector machine, there can't be any points in between that place. Let me write it out. There can't be any point in this place. The reason is because support vector creates a margin where there are no points. So we only have points that are in the gutters and points that are away from the gutter, not in the margin. So let's now see exactly how Lagrange multipliers work. Rule 1 for Lagrange multipliers. Let me write it out to be rules of Lagrange multipliers. Let's call it rules of Lagrange multipliers. Alright, so put this correctly. Alright, it's fine. First, for all non-support vectors, alpha is equal to 0. So for points that are not in the gutter, they are not support vectors. For instance, this point E, alpha is 0 because it does not support the decision boundary. It does not have any effect in the decision boundary. Remember, we say that the Lagrange multipliers try to explain how the points or the vectors support the decision boundary. Alright, so note that alpha will never be negative. So it's either alpha is 0, which means it doesn't have any support for the decision boundary, or is more than 0, that is greater than 0. So it can't be negative because it will not make any sense. So let's continue from another slide. Another law or another rule of Lagrange multipliers or alpha value is that the sum over all support vectors equals 0, right? So for all support vectors, we have the sum over all support vectors is 0. We added this I to be able to capture both the positive and negative. Remember, we said that yi is either positive or negative. So we added this I. Yi is equal to plus or minus. So summing over plus and minus support vectors, plus and minus data points or vectors, it has to give us 0. And that also implies that sum of all positive support vectors equal to sum of all negative support vectors. PSV means positive support vector and NSV means negative support vectors, right? Fine. So when we use it this way, it means that the negative ones actually cancel out the positive ones. So alpha is the weight of each of the support vectors in terms of how much they contribute to the decision boundary. If the point or the vector doesn't contribute anything, then it is 0. If it does, then it is greater than 0. Alright, let's see. So this becomes our equation 4. So you can see Lagrange multipliers is very simple to understand. It simply tells us how much the vectors contribute. Okay, so we now have equation 1. For the 3 data points, we are summing over all of them. Of course, you know that alpha E is equal to 0, and that is why it is not making the equation alpha E equal to 0. So for every other point, 1, 2, 3, alpha A plus alpha B equal to 2 alpha D. Okay, so let's continue. Supportiveness value times the classification times the coordinate equal to W. Meanwhile, let me just help you understand how we got this equation, because we actually will need 3 different equations to be able to get alpha A, alpha B, and alpha D, because there are 3 unknowns, meaning that we need 3 equations. So this actually will be the first equation to use. So alpha A is positive, so actually 1 plus alpha B, 2 alpha D, as you can see, 2 alpha D. Alright, so supportiveness value, this is given, times the classification times the coordinates equal to W. So writing it in using the formula, we have summation of alpha A plus alpha I times the class times the coordinate equal to W. So meaning that W is equal to summation of the positive alpha values times the coordinates of these values minus the negative ones times their coordinates. So the coordinate, of course, you know, D is 2, 2. This is 1, 3, right? So I can just write it out for you so that it's a little less confusing. If you have any question, feel free to ask me. This is what is 1, 3. I'm sure you know this is what 2, 2. You can actually read it from there, and this point is 1, 1. So it becomes clear. Alright, so continuing from where we stopped, we have this equation we've written is given. Now using from the example, we have this, right? So this actually derived from this. So we have x. This I'm going to make it a little clearer for you. We have x a equal to what? Equal to what? 1, 3, because they are vectors. X b equal to 1, 1, and x d equal to what? 2, 2. So that is how we came up with this equation, and we are multiplying by alpha values, and this is what we have. So from here we can actually form 2 equations, because the first equation 2 minus 2 is equal to alpha A times 1 plus alpha B times 1 minus alpha D times 2. So the next equation gives us, from this one, 0 is equal to alpha A times 3 plus alpha B times 1 minus alpha D times 2. So this, we already have the 3 system of equations that we would like to use to calculate the alpha values easily using system of linear equations method. I'm going to allow you to do that on your own and get me the values of alpha A, alpha B, and alpha D. So if you succeed in getting it, let me know in the comment box. And whether you succeed or not, we'll be able to trash this in tutorial 6. I'd like to thank you for viewing, and also remember to subscribe so we see you in tutorial 6.